Okay. Welcome to ESE Online and ESE Engineering Academy. Myself, Vagula Madhushekhar, faculty at ESE Engineering Academy and ESE Online. I am here to discuss about the preparation strategy for GATE and ESE. Okay, na? For GATE and ESE, 2024 mechanical preparation strategy, especially for this material science subject. Okay, and I'm working from last 8 years onwards at ESE Engineering Academy. I did my MECH from IIT Roorkee with industrial engineering as a specialization. Now, if we talk about this material science for GATE and ESE, most of you people think that the material science is like a dry subject, theory subject. So they felt difficulty in studying this subject, and also they felt that it is somewhat less weightage. But if you observe carefully, from last 3-4 years onwards, the weightage somewhat increased. Means actually like 2-mark questions, a good number of 2-mark questions, like 1 or 2 questions they are asking, and 1-mark questions also they are asking, right? So first, before going to that, I'll explain the syllabus, okay, related to the GATE and the ESE and also other competitive exams, especially from this subject. Okay. Now, if we talk about this syllabus, especially for this mechanical GATE, okay, na? For this mechanical GATE point of view, GATE 2024 point of view, there were 4 topics actually from this material science. That is, one is crystallography, second is material properties and testing, third one is phase diagrams, fourth one is heat treatment. And actually this powder metallurgy syllabus, this powder metallurgy is there in the production and industrial engineering topic, but it is related to material science. That's why I am also including this topic in this syllabus. So for GATE mechanical point of view, there were 5 topics: crystallography, material properties, phase diagrams, heat treatment, and powder metallurgy. So first we'll see the weightage of this material science from this mechanical background. Now see here, okay, for 2023 there is only one set, okay. They asked 1 1-mark question, 2 2-mark questions. Now see here, okay, 2-mark questions are 2, right? So 4 marks total, and this is 1 mark. So total 5 marks, okay, total 5 marks in 2023 GATE they asked, okay, 2 1-mark questions, that is 4 marks, and 1 1-mark question, total 5 marks they asked. And in 2022, you can see there are 2 sets, set A and set B. In case of set A, 1-mark questions 3, 2-mark questions 1. So the weightage here also 5 marks. And in set 2, set B, there is only 1 question they asked. And in 2021 also, okay, so 1-mark questions 2 in set 1, 2-mark questions 0, but in set 2, 2-mark questions 1 and 1-mark question 1, like that they asked. So from this, what I am saying actually, the weightage is somewhat increased in 2023 compared to 2020, 21 and 2022. Okay, now? So that's why you should also focus on this subject, because there are only 5 topics. Okay, there are only 5 topics, and these 5 topics are like Some of the topics are theoretical, some of the topics are numerical. Okay, if you go through this subject once, you will get lot of interest. You will learn so many things from this subject. Okay, right. I'll discuss elaborately what are the things you should cover from each topic. Now, see here, in case of production and industrial engineering, for production and industrial engineering, there is some more weightage is given to this subject, because the production and industrial engineering point of view, there's more weightage for material science and production. And also the syllabus, if you compare with the gate mechanical, there is this is somewhat huge syllabus is there compared to this gate mechanical. Now first see this syllabus. One is crystallography. Okay, this is common for gate mechanical and PI. See, remember, this is common for mechanical gate and PI, same. And material properties and testing also, okay, common for mechanical and PI. And phase diagram is also there for mechanical and PI gate, Heat treatment also there for both mechanical and PI, and powder metallurgy also there for mechanical and PI. Now the last two topics, they are actually extra syllabus given to the production, that is ferrous and non-ferrous alloys. So in this ferrous and non-ferrous alloys, you should focus on different types of steels and cast irons, and also you should focus on aluminum alloys, magnesium alloys, nickel alloys, copper alloys, super alloys. You should focus on these materials. And then non-metallic material, the word is given simply a non-metallic material. The non-metallic material is not it's seeing that it's a small word, simple word, but it includes so many topics, so many concepts here. That is, polymers also comes under this category, non-metallic materials. Ceramics also comes under this category. Composites also comes under this category. Simply given non-metallic materials, but if you see the previous year questions, they are asking questions from the polymers, ceramics and composites. That's why you should also focus on these topics. So GATE aspirants, please you should be careful about this material science. Okay, if you are going to attempt PI gate, production and industrial engineering gate, you should more focus on material science. There is a huge weightage is there, and also you should focus on, other than mechanical syllabus, you should focus on these extra topics, that is ferrous and non-ferrous alloys. You should also focus on ferrous and non-ferrous alloys. Let us see the weightage of this production and industrial engineering. See the weightage of this production and industrial engineering. Now, if you see this weightage, see here, this year they asked some good number of questions. Okay, 2 mark questions 3, 1 mark questions 2. So some good number of questions they are asking. You can take average weightage I am giving for this production. Okay, average weightage I am giving for this production. That is, minimum you take 5 marks, and maximum you can take 10 marks. Okay, maximum you can take 10 marks, especially from this material science topic they are asking. In case of gate mechanical, the minimum marks 2 marks, maximum marks you can take 6 marks. Okay, for gate mechanical, remember for gate mechanical point of view, average weightage, if I consider average weightage, if you consider that average weightage, minimum 2 marks you can take, and maximum 5 marks, sometimes 6 marks also you can take. So this is the weightage analysis for gate mechanical and production. But production, there is somewhat huge weightage is there, extra syllabus is there compared to mechanical. Okay, now next important thing is ESE. For engineering services exam, okay, For engineering services exam, there is a huge weightage, especially from this material science. Okay, there is a huge weightage, especially from this material science, because in ESE exam, in ESE exam, there were 3 papers. Paper 1 is related to general studies and engineering aptitude. Paper 2 is related to the technical paper, and paper 3 is related to mains. Okay, now in all these 3 papers, there is a huge weightage for this material science. You may get doubt, sir, why this much importance is given to this material science. See, the UPSC thought that as an engineer, you should know about the basic things like materials. Let us consider a civil engineer. He should know about what type of steel materials they are using in their RCC beams. They should know that, what is the percentage of carbon in steel. And also, mechanical engineers, they should know about different properties of different alloys. Nowadays, the world is moving towards advanced materials. Nanotechnology, we are moving towards the nanotechnology. That's why, every engineer, they should know about the properties, of material. If you want to make something, let's simple, you take an example of, you want to make a pen. If you want to make a pen, you should select the material, what material you are going to use. Let us say, will you make this pen with metal? There is a more weight, you can't write here. Will you make this pen with a ceramic material? You can't, brittle material. Like that's why, for each and every component, if you want to make, as an engineer, you should know about the material. The electrical people, they should know about the electrical materials, like what type of material they are using in overhead electrical wires. Electronics people, they should know about what type of materials they are using to make a semiconductors. That's why there is a huge weightage of this subject, especially for ESE students, ESE aspirants. Because remember, this subject is there in case of ESE, this subject is there in paper 1. This subject is there in paper 1, that is general studies and engineering aptitude. In paper 1, general studies and engineering aptitude, that is, they are mentioned in this paper 1 syllabus, basics of material science and engineering. Basics of material science, basics of material science and engineering, basics of material science and engineering. But they did not mention anything about the syllabus related to this material science. So it is common for all branches, mechanical, civil, electrical, electronics. So as an engineer should know about the complete materials, what type of materials we are going to use to make a particular thing. Right? That's why it is a common syllabus for everyone. The weightage of the subject here, remember, the weightage of the subject here, every year they are asking 10 questions too. Remember, 10 to 14 questions they are asking from this basics of material science. Now see here, 10 to 14 questions average, you take 22 marks only from the paper 1. Only from the paper 1, 22 marks they are asking. Now from paper 2, now see the weight is here. From paper 2, see the weight is here. In 2013, 2023, they asked a very good number of questions. 15 questions they asked. 15 questions means 30 marks. 15 questions means 30 marks. Now see here, in paper 1, remember, in paper 1, 22 marks. In paper 2, 30 marks. And in paper 3 mains also some 70 marks. So there is a huge weightage, 120 marks. So if you want to get a good ESE rank, this will give you a good fetching for you. If you focus more on this subject, that too, this is not like too much complex. It's a very easy subject, basic fundamentals. Right. Now, for this ESE point of view, what are the topics you should focus? What are the topics you should focus? That is crystallography. Crystallography, this is also there in GATE, and material properties and testing, phase diagrams, heat treatment, metallic and non-metallic materials, nanomaterials. Remember, they added this nanomaterial in 2017. Nanomaterial, okay, in 2017 they included the syllabus, because you should know about what is nanomaterial, because the world is moving towards the nano advanced material, right? So nanomaterial, and also preventive methods of corrosion. So this corrosion is also, there's a huge impact on Indian GDP. Do you know? Do you know at least 2% of GDP is basically because of loss of material that is due to the corrosion. Loss of material due to corrosion, that cost is approximately equal to 2% of GDP. Huge value. That's why they also included this preventive methods of corrosion in your ESE syllabus. So these topics you should focus, okay, to score good marks in ESE paper 1, paper 2, and also in mains. Okay, now, right. Now see here. So I discussed the weightage analysis for GATE mechanical, GATE production and industrial engineering, and ESE. Now I am going to discuss each topic. From each topic, what type of questions they will ask you, from which areas they are asking questions for these competitive exams, that I am going to give. Now see here, in case of crystal structures, you should focus on types of crystals. Remember, types of crystal structures. You should focus on types of crystal structures. So especially you should focus on simple cubic structure, body-centered cubic structure, face-centered cubic structure, diamond cubic structure, and hexagonal close-packed structure. So from these 5 structures, every year or every alternating year, or for ESE point of view, every year they are asking questions from these 5 types of structures. And after that, from the crystallography, you should also focus on crystallographic directions. You should also focus on crystallographic directions and planes. You should also focus on crystallographic directions and planes with respect to their densities, linear and planar densities. Numericals they will ask you from this concept, but till now they didn't ask any question from this directions and planes, especially for GATE. ESE point of view, they asked Miller indices type of questions, but there is a huge hopes or chances are there to ask a question from this crystallographic directions and planes. And then there is a chance to ask a question from defects, imperfections. So out of these, there are so many defects. You should also focus on the point defects, and especially point defects, basic definitions they will ask you from the point defects, like what do you mean by Schottky defect, Frankel defect. Okay, this type of questions they will ask you. And also from line defects, edge dislocation and a screw dislocation, you should focus. Okay, and finally from this topic you should also focus on X-ray diffraction method, that is Bragg's law. Okay, from this topic you should also focus on X-ray diffraction method. We call it as Bragg's law. Okay, na? From the Bragg's law you should also, there is a chance to ask a question. So from these areas you should focus, okay, na? Especially from the crystallography. Okay, these are the topics, subtopics I am giving, important subtopics. From these subtopics they will ask you questions. Right. Now, see here, there is one question. There is one question in ESE 2019 from the first unit. There is one question ESE 2019. That is what? The atomic packing factor, okay? The atomic packing factor for BCC. Okay, the atomic packing factor for BCC is 0.68. The atomic packing factor for BCC is 0.68. Okay, now, so you should focus, you should prepare a table. In general, in physical class, online class, live classes, I usually give a table of all the 5 structures. You should also read the table number of times so that you can easily guess the answer. So atomic packing factor of simple cubic body-centered cubic structure, straightforward question they asked. Now, see here, then the number of atoms per unit cell, the number of atoms per unit cell and number of slip systems respectively for face-centered cubic structure. So they asked about FCC structure again here in GATE 2018. Okay, they asked about FCC structure in GATE 2018. Now see here, if I consider a cube, let us consider a cube now here. Okay, now see here, this is, okay, now this is a cube. In face-centered cubic structure, there are 8 atoms are at 8 corners. Okay, 8 atoms are at 8 corners. And 6 atoms are at 6 face centers. 6 atoms are at 6 face center. Like that, the atoms present. So they are asking the effective number of atoms. Okay, what do you mean by effective number of atoms here? Here, if I take this atom, only some fraction of the atom is present inside the unit cell. That is actually 1/8 of the atom. Like that, there are 8 corners. Each face center, at each face center only half of the atom. So at every corner there is 1/8 of the atom, like that 8 corners, plus at every face center half of the atom, like that 6 face center. So the number of atoms, effective number of atoms inside the unit cell is 4. Okay, effective number of atoms, and also the slip systems are only 12. Okay, so this is the correct answer for this question. This is the correct answer. So slip systems actually will get from the material properties and testing. Okay, now, right? So like this type of questions they will ask you. And there is a question from the Miller indices especially, okay, that the question here it is asked in ESE 2016. Random questions I took, okay, now. The Miller indices of a metal in a plane are proportional to, see, remember, the Miller indices are nothing but reciprocals of plane fractions. Okay, now, reciprocals of plane fractions. Miller indices are nothing but reciprocals of plane fractions. That's why A is the correct answer. Straightforward, simple question they asked. And if we talk about material properties and testing, this topic is very, very important. Not only important for your GATE and ESE exam, but also very, very important for other competitive exams and also for interview point of view, especially for mechanical people. As a mechanical engineer, you should know about the basic mechanical properties of materials, like what do you mean by strength, what do you mean by toughness, what do you mean by hardness. So this type of questions they will ask you, especially from this topic, especially in interview. Even though no one will say that my interested subject is material science, because everyone felt the material science is difficult subject. But as in an interview panel, definitely they'll ask you some questions from these basic fundamentals, especially from the mechanical properties of materials. So what type of mechanical properties you should learn for your exam and interview that I'm going to give? See here, what type of mechanical properties you should focus? Now see here, you should also focus on true stress, and true strain. True stress and true strain. Okay. numericals they will ask you from this topic. Remember, numericals they will ask you from this topic. Numericals they will ask you from this topic. And the second is, okay, strain hardening mechanism. Strain hardening mechanism. Okay, second is strain hardening mechanism. They will ask you questions from strain hardening mechanisms. Okay, mechanisms like power law of strain hardening. Power law of strain hardening. From the power law, they will ask you questions. Okay, na? That is numericals only. From this also, they will ask you numericals. So you should focus, especially gate point of view, numericals they will ask you. For IS point of view, theoretical type of questions they will ask you. And then different mechanical properties of materials like ductility, like how to measure the ductility of material, how to measure the ductility of material and malleability of material, and also how to measure the theoretical density. This is also very, very important for ESE and GATE. Theoretical density questions they will ask you, numericals they will ask you. By using a formula, you can able to calculate the density of metal. And then they will also ask you questions from hardness, different hardness methods, especially numericals they will ask you from Brinell hardness number. They will ask you questions from Brinell hardness number. And also they'll ask you questions from, okay, toughness, okay, toughness, interview point of view also these things are important. Resilience, toughness, resilience, and proof resilience, okay. From this they will ask you questions, And then listen carefully, from the creep also sometimes for some competitive exams they will ask you questions. And creep, not only creep but also fatigue, they'll ask you questions from these material properties. So as an engineer, as a mechanical engineer, you should know about the properties of these materials. Now, see here, there is a question that is actually ESE 2015. Okay, the question here it is, copper has FCC structure. Its atomic radius is 1.28 angstroms and atomic mass is 63.5 grams per mole. The density of copper is. And also if you observe carefully, all these options have 8.9, 8.9, 8.9, 8.9. Only the difference is units. This is a very simple question, you no need to calculate. Actually, in ESE point of view, calculator is not allowed. So without using calculator, you should be able to solve the question. But here, even you no need to solve the question, directly will get. Let us consider, okay, density of iron is 8. So let us say 7.87. Listen, consider density of iron is 7.87 grams per centimeter cube. Okay, grams per centimeter cube, grams per cc. That you can write it as 7,870. Some textbooks 7,850 like that. So kg per meter cube. So from this you can understand for a metal more or less in terms of thousands kg per meter cube. Now if you observe carefully, this is not correct kg per mm cube. This is the correct answer because 8.9, that means 8,900 kg per meter cube. The density of copper is more than the density of iron. So from this you will get to know, just based on the units you will get to know. So this type of questions they will ask you for your exam, right? This type of questions they will ask you for your exam. Next is the phase diagrams. This phase diagram is a very important topic for GATE and ESE and other competitive exams. Number of times they asked questions from this phase diagram. We can say every year there is one question from the phase diagram. Okay, so you should focus. Remember, there are three basic phase diagrams important for your exam. Okay, you should focus more on iron cementite phase diagram. Iron cementite phase diagram. This is one very important here. Any competitive exam you take, definitely there must be one question. For GATE point of view, every year there is one question. So very important. Remember, for GATE point of view, they will ask you the numericals. Generally, most of you people, those who are new for this GATE, they will think that material science is completely theory. Even first of all, iron cementite phase diagram is completely theory. There is no numericals like that. But no, it is wrong concept. See here, the number of numericals they'll ask you from the lever rule concept. I'll give you that. Then second most important phase diagram is lead and tin. Okay, eutectic phase diagram. Lead and tin eutectic phase diagram. Lead and tin eutectic phase diagram. You should also focus on this. And third important diagram is copper nickel isomorphous phase diagram. Copper nickel isomorphous phase diagram. You should also focus on copper nickel isomorphous phase diagram. So these three types of phase diagrams you should focus, including numericals from the lever rule concept. Including numericals from lever rule method, lever rule concept, numericals they will ask you. And iron cementite phase diagram, theoretical concept questions also they will ask you. Okay, and also from this phase diagram you should also focus on Gibbs phase rule. You should also focus on Gibbs phase rule because they are asking questions sometimes from the Gibbs phase rule also, and sometimes Hume-Rothery rules also they'll ask you questions. Okay na? So you should also focus on Gibbs phase rule and Hume-Rothery rules to make a substitutional solid solution. So from the phase diagram, mostly they'll ask you questions from these models. Okay na? From the phase diagrams, mostly they're asking questions from this model. Now let us see this question in GATE 2018. In GATE 2018, what they asked, see here, denoting L as liquid and M as solid in a phase diagram with the subscripts representing different phases. A eutectoid reaction is described by, remember, this eutectoid reaction exists in iron cementite phase diagram. It's a Latin word actually. Eu means nice, tectic means melting, nice melting, we can say that is. So, or otherwise two solids upon heating transforms into one solid. So here solid is represented by M, letter M, right? So here, see here, one solid upon cooling transforms into two. So first option is right. This is the correct one. First option is right. That is the correct one. Okay now. Like this type of questions, sometimes numerical also they will ask you. In the next session, like important concept, while discussing important concepts, I'll explain about this structure, about this phase diagram. Don't worry. Let us consider heat treatment. Heat treatment process is easy topic. Actually, most of you people think that heat treatment is somewhat difficult, complete theory, very difficult to remember the terminology like that. But once if you read that, It is the easiest topic out of all the material science topics. And for every competitive exam, there must be a question from the heat treatment. Theoretical type questions, very easy questions, basic standard questions they will ask you. I'll give different heat treatment processes. You just focus on these processes, that is more than enough. See here, what are the processes you should focus? Remember, hardening process, okay na? Hardening process you should focus. Annealing process you should focus. In annealing process, there are different types of annealing process are there, okay? And then normalizing process you should focus. Normalizing, and then tempering process you should focus. Tempering process you should focus. And then T diagram is important. From this TTT diagram, you should also focus on us tempering process, and Mar tempering process you should focus. Okay, from the TTT diagram, you should learn about us tempering and Mar tempering. And also you should focus on different surface hardness methods, surface hardening methods like flame hardening, induction hardening, carburizing, nitriding, cyaniding. And also you should focus on precipitation hardening process. So if you follow these many processes, definitely you will get a question for GATE from these processes in every year. And also for ESE point of view, some 2 questions they will ask you from these processes. And other competitive exams also there is a good weightage is there from this topic, theoretical type questions. So what you should focus in each process? Remember, in each process what you should focus, I'll tell you, listen. In each process you should focus on objective of the process, means what is the purpose of that process, aim of that process. Okay, aim of that process. Second, that process for what type of materials we are applying, type of materials, for what type of materials we are applying, is it ferrous and non-ferrous? Like precipitation hardening is there, that is for non-ferrous alloys it is applied, like that. Type of materials, and then you should also focus on temperature limits, up to which point of temperature we should heat, and then type of cooling after temperature limit, type of cooling, what type of cooling we are doing after that, this type of cooling, resultant material, the name of the resultant material, name you should remember, name and properties of that resultant material you should remember. So once if you focus on all these things in each process, let us say hardening process, what is the objective of hardening process? What are type of materials we are using for this hardening process? What are the temperature limits for this process? What type of that material? Name of that material and properties of that material. So you should focus on all these topics, then it's a very, very easy topic. Now you see in GATE 2019, they asked a question. Remember, from the heat treatment, they will ask you only a theoretical type of questions. From the heat treatment, they will ask you only a theoretical type of questions. So what is the question here? Hardenability of steel. Remember, hardenability of steel actually from the hardening process. In hardening process, after heating the material, we are quenching in water. So by quenching in water, the material forms martensite. So, but inner core of the material, there is some retained austenite. So, outer layer is a hard phase martensite material. So, hardenability means it is the depth from the surface of the specimen up to which martensite is present. Otherwise, simple language you can say it is the depth from the surface up to which a material consists of a good hardness. Now see here, different options if you read, the ability to retain its hardness when it is heated to elevated temperature. No, not correct. I am talking about the depth, hardness. See, hardness and hardenability difference, you know, if I create a scratch, if it creates scratch easily, low hardness. Now, if it won't create scratch from the surface up to how much depth it is, that is depth of hardenability or hardenability, right? The second question here, second option here it is, the depth to which required hardening is obtained when it is austenized and then quenched. Austenite and then quenched. Yes, this is the correct. Maximum hardness that can be obtained, not correct. The ability to harden when it is cooled, not correct. So, B is the correct answer for this question. B is the correct answer for this question. Right. Now, non-metallic materials, if I consider, from the non-metallic materials, actually this non-metallic material is not there for gate, only for ESE and for PS, like a production and industrial engineering, I think gate it is there, right? For PI, for gate PI and ESE, this topic is there. Now, in this topic, okay, in this topic, you should focus on composite materials, different composite materials, okay, and also you should focus on polymers. You should focus on polymers, and also you should focus on ceramics. These are the topics you should cover, especially from this non-metallic materials. And there is one more topic, that is powder metallurgy. From the powder metallurgy also they will ask you questions, but rarely. Rarely they will ask you questions from the powder metallurgy. If you cover some basic things related to this powder metallurgy, that is more than enough. Right? So these are the topics you should focus from the non-metallic materials. So let us consider a question here. Let us consider, this is actually an IES question, not for GATE. For GATE point of view, they will not ask you this type of questions. Now see here, in case of this, listen, statement type question they asked, statement type questions they asked, statement 1 and statement 2. In case of statement 1, okay, fiberglass is a polymer composite made of a plastic matrix contained in fine fiberglass. Yes, we can say the best example is optical fiber. Okay, the optical fiber is a glass fiber reinforced polymer. That glass fiber, remember, glass fiber reinforced polymer and carbon fiber reinforced polymer, aramid fiber reinforced polymer. You should focus on these materials because they are in advanced materials everywhere at present. Everywhere we are using these materials. You know, aircraft, if I take aeroplane, more than 50% of the materials are composite materials. That's why I'm saying there's a huge weightage is there in outside for industry, especially if you want to make anything, something that material is mostly made up of composite. That's why, okay, they're asking questions from the composite. So let us consider this fiberglass. A fiberglass is a glass fiber reinforced polymer. In this glass fiber reinforced polymer, glass is a reinforcement phase material. It is in small wire form. Surrounded by that glass fiber, okay, a polymer matrix is there. So in the polymer matrix, we are arranging the glass wires or glass fibers. So by arranging that will give you very, very high strength. The best example is optical fiber. And also one more example I'll tell you from this. Listen, in olden days, if I take the vehicle mirror, vehicle glass, that is pure, it is made up of pure glass. The weight of that glass is more. And also, if you apply a sudden impact load on the glass, it will broken down into pieces. But nowadays, we are using G of RP, glass fiber reinforced polymer. So in that glass material, okay, glass is there, polymer is there, that's why it has a good strength, good impact strength and less weight, right? So that is actually a glass fiber. So they are asking question related to that glass fiber. Now the statement 2, if I take the fiberglass acquires strength from polymer and flexibility from the glass, it is absolutely wrong. Remember, in case of glass fiber reinforcement phase material, remember, in case of glass fiber reinforcement phase material, okay, the reinforcement phase material is glass wire or a glass fiber, and matrix phase material is polymer. Generally, if I take pure glass, it is a high strength but brittle. That's why we are adding polymer. So by adding, okay, polymer, ductility increases, right? Flexibility increases. So by adding glass, strength will increase, and by polymer, flexibility will takes place. Flexibility is going to be takes place. So glass fibers acquires strength from the polymer and flexibility from the glass. So statement 2 is wrong. So option is C. Actually, there are 4 options. First option, option A, represent what you know. Statement 1 and statement 2 are correct, and statement 2 is correct explanation for statement 1. But here statement 2 itself wrong. So first option is eliminated. Second option is what? Statement 1 and statement 2 both are correct, but statement 2 is not correct explanation for statement 1. Here also second option is deleted because statement 2 is wrong, not correct. And third one is statement 1 is correct and statement 2 is incorrect. So that option I am giving C. D option is statement 2 is correct and statement 1 is incorrect. But statement 1 is right, statement 2 is incorrect. That's why C option I am taking. Now, this is actually related to non-ferrous materials. Remember, sometimes they will also ask you questions from non-ferrous alloys. Remember, they will also ask you questions from the non-ferrous alloys. I will give you some important things you should focus on these materials, especially compositions. Okay, Babbitt metal, this is also known as a white metal, important for exam. Any competitive exam, Babbitt metal or white metal is important. And also German silver you should focus. German silver you should focus. And Admiralty brass you should focus. Admiralty brass you should focus. And also you should focus on super alloys, nickel alloys. Super alloys are nothing but nickel alloys you should focus. Okay, now like these materials, okay, you should focus on these materials. Then definitely there must be a chance to ask. Within the nickel alloys there are so many, okay, like inconel, monel metal, right? So that like that they'll ask you questions, basic questions they'll ask you like compositions, especially compositions. So Babbitt is an alloy of, see if you see the options here, okay, tungsten is not there in the Babbitt, first point. And copper is there, tin is there, not only copper and tin, and also antimony is also there. This is also there, that's why nickel is not there, right? These things I am not giving, so more weightage I am giving to this. So antimony is there. Lead also there, but lead option is not there here, so I am taking for D option, right? Now let us take another question in GATE PI 2017. Now here you can see the question here. In a glass fiber reinforced polymer, see again there is a question from the glass fiber, important. Okay, which with long fibers, the role of matrix. See, they are asking a question, role of the matrix. What is the purpose of the matrix they are asking? Now see here, P statement, support and transfer the stress to the fibers. Okay. Reduce the propagation of crack. Yes, correct. Carry the entire load. Is it carry the entire load? No, no. It will not carry the entire load. Protect the fibers against the damage. Yes, it will protect the fibers against the damage. Support and transfer the stress to the fibers. Yes. Role of the matrix they are asking. Okay, now reduce the propagation of cracks. Yes, and this. So we can say P, Q and S are the correct answers, so that we can say C is the correct answer for this question. So this type of questions, basic standard questions they are asking for GATE and ESE. Now, if you want to learn many things, especially from the material science, if you want to get a good score from the material science, mostly we will provide everything. We will provide a classroom notes, we will also provide online classes and self-paced programs also there. Actually, my class is more than enough for this material science. In case if you want to become expert in this material science, you just go through the these textbooks, that is Material Science and Engineering by William D. Callister. William D. Callister. Material Science and Engineering by William D. Callister. Willy publication. It's a very, very good book, excellent book. And one more Indian author textbook, that is Material Science and Engineering by V. Raghavan. Actually was a IIT Madras professor, so it is also an excellent book, right? So these are the sources for this material science. Now, some of you people will do mistake by reading so many things, by doing research from a subject like that. So I'll give you some, what are the important things you should focus. See here. So you just focus relevant to the exam. What is the syllabus? What type of questions they are asking? So just read relevant to the exam. Don't go beyond the boundaries. Waste of time. And concept related to that syllabus. And numericals, remember, for GATE exam point of view, 99% numericals they'll ask you. That's why you should focus on numericals. You should remember each and every formula. If any one of your friend asks you at night, when you are in deep sleep at night, 2 o'clock, what is the rolling force like that, then you should give the formula. Like that you should prepare. And shortcut techniques, you should also write short notes and write test series. We are providing good number of test series to get a good rank for you, right? So you should focus on all these things. Then don't do the research work, Don't do the research work, okay? And the materials, class notes, my class notes and my coaching material, previous year GATE questions and IES questions, bits and bytes and short notes. If you prepare, this is more than enough for your exam, right? So this is the complete information about this material science preparation strategy. In case if you get any doubt related to this subject, I'll give you my mail address also here, that is mailsearv@gmail.com. This is my mail ID. If you get any doubt related to this material science, you can ask me. Material science, metal forming, some production topics, metal forming, sheet metal operation, and also renewable energy, maintenance engineering. So from these subjects you can ask me any doubts. I'll give reply to you. Thank you.